we got a cart that's in motion. And it's the same situation that we had up above. We got an applied force of 5 newtons acting on this cart. We've got a displacement that the cart's going to experience of 20 meters. So we're rolling it along at 20 meters. Maybe it's a rocket cart. I don't know. The angle between the applied force and the displacement is 0 degrees because we're going to say that the applied force is pointing in the same direction that this thing is traveling in. The mass of our cart is 20.0 kilograms. And it starts off not from rest this time, but at 5 meters per second. And we'd like to figure out what speed it gets up to at the end. How fast is it going at the end? Now, what we said once before was that the amount of work that I'm going to do on this thing, since I'm not going to raise it to a higher height, I'm not going to give it more gravitational potential energy, I must just be trying to give it kinetic energy because it's going to stay at the same height, right? So this work that I'm doing is all going into changing energy, but specifically into changing its kinetic energy. The work that I'm doing could be force times displacement times cosine of theta, because we've defined work that way, and that would be equal to 1/2 mv2 squared minus 1/2 mv1 squared. Now at this point, I can't zero out the v2, because the v2, sorry, I can't zero out the v1, because the v1 is equal to 5 meters per second, not 0. The only thing I can do to simplify this is to say, well, theta is equal to 0, so that guy's going to reduce to a 1. So then I can say, all right, well, what am I trying to get? I'm trying to get v2. I'm trying to get the final velocity. So my algebra brain kicks in, and I say, all right, well, I'm going to take the stuff that doesn't have v2 in it over to the other side. So I would say, all right, well, I got force times displacement, and then I'm going to subtract, sorry, I'm going to add to both sides, plus 1/2 mv1 squared. See, I'm just taking that guy and I'm adding it to both sides. That's going to eliminate it from the right-hand side, and it's going to leave behind only 1/2 mv2 squared. Remember, the name of the game is to try and figure out what the final speed of this cart is. I'm trying to get v2. So if I'm going to do that, I'm going to have to do the same thing to both sides. Actually, I think just for communication purposes, I'm going to white this out and move it over just a little bit. I'm going to say I got 1/2 mv2 squared. And I'd like to propose that I could do this operation. I can put that in brackets and multiply both sides by 2. But I would have to multiply all of the left and all of the right by 2. The reason I'm really drawing your attention to this is I have seen so many students in the past multiply the right-hand side by 2 to get rid of the 1/2 and only multiply one of the terms on the left-hand side by 2. Don't do that, okay? It's a silly move, and you're better than that. So I say, all right, 2 times force times displacement plus 1/2 mv1 squared equals mv2 squared. And then what's the next thing that I should do? Yeah? Yeah, divide by m. And don't forget, I'm going to divide by m. Oh, I told myself I would color code my operations in red. Oh well. But the m's are going to cancel out. But whatever I do to the right-hand side, I got to do to the whole left-hand side. Don't just divide one term by m. Divide the whole left-hand side by m. And for those of you that are pros at this, I'm sorry for slow-talking it, but for those of you that were going to make a mistake on this, you got to do it, okay? You got to divide both, well, the whole thing, including both terms, by m. And of course, are you guys okay with me just square rooting both sides right now? I don't want to be too lazy, but we could do that whole operation all in one go, right? And don't forget you're square rooting the whole left-hand side. Now that brings us down to this form. V2 is equal to 2 times force times displacement plus 1/2 mv1 squared, and bracket, all divided by m, all square rooted. I guarantee you, at the beginning of this course, that would have looked like, oh my gosh, that's a lot. If it feels better now to look at that, that's good. That's progress. If it doesn't feel better, then we should talk. But we should be more comfortable with the algebra at this stage. And we should just be able to sub in our values. 2 times, what was the applied force? 5 newtons?
Yeah.
Times displacement of 20 meters. Plus 1/2. 20 kilograms. You can put extra brackets in there if it makes you feel better. 20 kilograms times 5 meters per second squared, close bracket, all divided by 20 kilograms, and all square rooted. And nope, you can't just randomly cancel anything out. Let's just put it all into our calculators. Now, if it helps with your page layout, by all means, give yourself a little workflow arrow. I'll wait for you guys to put it into your calculators. If you can give me like a little wave. I'll give you a hint. It starts with a 5, okay? The answer starts with a 5. I'll wait for you guys to go through the process. Make sure you can do the data entry on this one. Use as many brackets as you need. I can color code the brackets if you like, if it helps for your data entry for your calculator. This bracket here and this bracket here are partners. They're bracketing that whole numerator thing that's being divided by 2. Or sorry, multiplied by 2. Did anybody get this one that starts with a 5? What'd you get?
5.9161.
6.1? Yeah, that sounds good. I got an extra 0.79 on the end just because I was feeling exhausting or something. I don't know. But meters per second. How many sig figs do we have in this problem? Take a look at our givens. Does it look like 3? All right, so V2 is equal to 5.92 meters per second. Now, I know that when I square root this thing, there's going to be a plus or a minus, but remember, we didn't have a reference frame anyway, so all we cared about was the magnitude. Okay. Now, in this case, yeah, it's sensible to think that it must be to the right, but again, we didn't have the reference frame. All we cared about was the speed. Okay? Yeah, negative velocity could be a thing. So therefore, the car moves at 5.92 meters per second at the end of the push.